So I'd like to next invite Matthew Gibson. So he's study committee convener for power transformers and reactors. So Matthew.
Thanks very much, Angela. As Angela said, my name's Matthew Gibson. I'm the current convener of the A2 Australian Transformer and Reactor panel. And today I'll just give you a brief update of the activities of the study committee A2 throughout the year. So basically the scope of the A2 study committee includes all kinds of power transformers, all kinds of reactors and all transformer components, including the bushings, tap changers and anything else that can be basically bolted to the transformer. And as Tree said, so we take his electrons and then pass them on to A3. The activities of the study committee basically cover the full life cycle of the transformer in the 4 key areas sort of listed in the graphic there. So from specification and procurement of transformers right through to maintenance, diagnostics and the end of life activities. Probably the main event for this A2 study committee this year was the 2022 Paris session, as probably was the case for many study committees. This saw a return to in-person event, which was fantastic after so many years of online events. But the key theme for the A2 sessions this year was transformers for renewable generation and new technologies. The group discussion meetings focused on the 3 preferential subject areas that are listed up there, but I'll go through those a little bit more in the following slides. But the study committee also delivered a tutorial during the Paris session on transformer life extension, and that pretty much, I think, brought to a close the work of Working Group A255. So for each of the preferential subjects in the group discussion meetings, I've just listed a few of the key or interesting topics. I'll just go through quickly. So preferential subject 1 was experience and new requirements for transformers for renewable generation. And this covered some of the challenges in the design of step-up transformers for use in offshore installations. It covered a few of the things like high temperature design requirements because they're installed in very small confined enclosures, and some of the detailed design that has to go into mechanical stress distributions due to vibrations and swaying that you get on offshore platforms that you don't see in a standard onshore installation. And in the design of converter transformers for solar applications, there's specific harmonic content and frequency of switching and unbalanced loads all needed to be considered in the thermal and dielectric design of the transformers. There was also a fair bit of discussion on de-energisation or reducing the output of the transformers to 0 volts at night in the solar farm transformers to reduce no load losses when the sun's not shining. Preferential subject 2 was beyond the oil immersed transformer and reactor, and in this session there was discussion on alternative transformer design concepts. There's been successful in-service experience now with dry type transformers up to about 145 kV, and there's been some work in SF6 free gas insulated transformers in the areas of testing and design modelling using natural origin gases that mainly consist of nitrogen and carbon dioxide at high pressures. For use of alternative materials and insulating liquids for high temperature designs, there's positive experiences and installations now up to 574 MVA, but it was acknowledged that some of the high temperature liquid designs are still using conventional liquid temperature limits because of the limitations of accessories like tap changers, bushings and gaskets, so there's a bit more development work needed in that area. Preferential subject 3 was best practices in transformer and reactor procurement. And short circuit validation was one of the hot topics in this session. There was some suggestion that industry standard approaches could be improved using more sophisticated simulation tools like 3D, finite element, magnetic and nonlinear dynamic mechanical simulations. A mouthful, that one. Clamping pressures are directly related to the short circuit withstand capability of transformers, but they vary a lot over the life of the transformer. So there's some work being done on using built-in pressure sensors that can provide some real-time feedback of the changes in clamping pressure, and using these as inputs to various models. And one of the other interesting topics was validation of geomagnetically induced current capability of transformer and the design. So there's a number of numerical calculation methods that have been developed and presented that are being used to assess the electrical and thermal capability of transformers. But actually validating these in the field or in a test lab is turning out to be very challenging, as it requires special equipment and very large power sources. And depending on the size of the transformer, that could be connection to the system, which is a little impractical. So the study committee currently has 3 joint working groups active. It has 10 single stream working groups and 1 task force, and those are all listed on the slide there. The bottom 3 in the table in bold there are 3 new working groups that have been established just in 2022. But the Australian and New Zealand panels do have a reasonable representation through these working groups, and I've put those names in green up there on the slide. In terms of upcoming work, there are 3 new working groups and 1 new task force that have been set up, that are soon to commence or have just commenced in late 2022. Working Group A269 was set up to review technical brochure 445, which is a guide for transformer maintenance, and provide a bit of an update on that. Interestingly, that brochure is the most downloaded brochure, I believe, in the eSigray website, so the study committee felt that it would be, it's about 10 years old now, so it would be a good time to give it a bit of an update and make sure it's current. And we do have Australian member Ross Willoughby, who was on the original working group, who will return to work on that group as well. And we also have Australian member Tara Lee MacArthur, who will be jointly convening a working group on guidelines for online DGA maintenance as well. So this study committee had a few publications this year. Technical brochure 861 was published in February this year, and that looks at improvements to partial discharge measurements in factory and site acceptance tests. There was a paper published in the Electra article earlier in the year on the condition of solid transformer insulation at end of life, and I think this one's a reasonably relevant one to the Australian industry as well. And there are 3 other technical brochures that are in their final stages and will probably be published maybe early next year, hopefully. There's also a green book published very recently, September this year, on transformer and reactor procurement. That green book provides guidance on industry best practice in transformer procurement, and outlines how to avoid making some of the common mistakes in the process. And again, we had a good Australian showing with Tara Lee MacArthur as one of the editors in the book, and Ross Willoughby as one of the chapter authors. The advisory committee has also commenced working on another green book, a new one on transformer and reactor life management, and that one is due for completion in 2025. So on to some of the local activities for the AU panel. Unfortunately, our planned transformer workshop day didn't proceed this year, but we did continue with a series of web tutes, and the topic this year was measuring water in transformers. So we had 2 web tutes delivered by a great range of overseas and local experts in their field. They were really well attended, and we had people dialing in from all over the world, which was a bit of a surprise. That was good. We also held a joint online event with the New Zealand A2 panel to discuss transmission transformer reliability, and during this we had an update from Dan Martin, who was one of the working group members, to give us an update on where they're up to in their work, and also had a discussion about how failure statistics are used by local asset owners with the intention of passing this information back to the working group for incorporation in their brochure. We haven't actually managed to have our panel meeting yet this year, but it's due to be held next Monday and Tuesday down in Melbourne, hosted by AusNet Services. Currently we have about 30 panel members and a good spread between utilities, manufacturers, academic institutions and some consultants. And we've recently had about 4 or 5 panel member changes as members have retired and passed on to new members to take their place. And just briefly looking forward to next year, we're going to hold a Transformer workshop again early in, that should be 2023. We'll also have our annual panel meeting. Probably one of the main events for A2 panel is a colloquium in Split, Croatia from the 4th to the 7th of October. And the preferential subjects for that are out there: digital twins, trends in transformer maintenance, and design performance in service. So the call for papers, I believe, is out for that now and probably closes early next year, in April, I believe. So that's all I had for today. Thank you very much.